In this tutorial, I want to calculate pH of a basic buffer made out of ammonia, a weak base, and ammonium chloride, its salt. So if you remember Henderson-Hasselbalch, we just plug in and we solve it. But this is POH because it's a base is equal to pKb plus log of salt over concentration of base. pKb is given is 4.75 plus log of concentration of the salt is 0.2. Concentration of your base ammonia is 0.4. So this is 4.75 plus log of less than 1 is negative, so this is minus 0.30. So this happens to be 4.45. Now don't forget this is POH, not pH. Since it's a base, we are expecting pH to be bigger than 7. pH plus POH is equal to 14. So from here and POH information, we can say pH is 14. Take away 4.45 and it's equal to 9.55. Okay, for those of you who don't remember Henderson-Hasselbalch, and let's say this is exam time, do not worry, ICE will always work. Let's just write the equation and solve it. So ammonia plus H2O will give you ammonium, NH4 plus, aqueous, and it comes from ammonium chloride, plus hydronium or hydrogen, H3O plus, plus hydroxide. Maybe that mistake was intentional, not really. Okay, so now let's just go after initial. Initial ammonia has concentration of 0.44, and you also have ammonium chloride of 0.200. None of hydroxide is there. Now there is change left to right, minus x mole goes away, plus x mole comes for each of the product. Then there is equilibrium. You have 0.40 minus x, you have 0.200 plus x, and you have x. Now Kb is simply 10 to negative pKb. So this also you need to feel comfortable and be able to do it. When you do that, it's 10 to negative 4.75 in the problem or data booklet, and you get 1.78 times 10 to minus 5 is equal to products over reactant. Now product is 0.2 plus x multiplied by x divided by 0.4 minus x. Now one of these x we are going to save after the assumption, and that's the one I'm going to write it in white. The other two go away because we write our assumption for the examiner. Kb is much smaller than 1, therefore 0.2 plus x is almost 0.2, and 0.4 take away x is almost 0.4. So life becomes easier. Now we solve for x, and x is concentration of hydroxide, don't forget. It's simply 0.400 multiplied by 1.78 times 10 to minus 5 divided by 0.2. And if you want POH, you just take negative log of this number. Negative log of this whole ratio. Since I wrote it, I'm going to continue writing it. 1.78 times 10 to minus 5 divided by 0.2. When you do, you also get 4.45, and then pH is nothing but 9.55. So ICE will work. Henderson-Hasselbalch is much easier. Whichever you prefer, just be able to solve the problem.